Hey guys, the objectives of today's video is to go through a slightly harder example of Mohr circle. So here we have a soil element lying on a plane inclined at 20 degrees above the horizontal, and there are shear stresses and normal stresses acting on the soil element, but one of the normal stresses is unknown, which is what we're trying to find. We're also given that the major principal stress is 100 kilopascals. And the second part of the question is interested in finding what angle does the plane of major principal stress make with the horizontal. So I'll go ahead and define 2 points. So let's say we have point A, its coordinates of sigma and -20. This is -20 because the shear stress causes the soil element to want to turn clockwise. And we also have point B, which is 30 and +20. Now I've gone ahead and plotted these points already on this Mohr circle. Don't worry about trying to do this to scale because we don't know what this normal stress is. So we're going to have to solve this Mohr circle analytically, so we can't rely on the graphical procedure in this instance. So because these stresses are acting perpendicularly to each other, we know that on the Mohr circle we can connect these 2 points with a straight line. Like so. So we also know this point here is the major principal stress. And we know that this distance here is 30 kilopascals. And this distance is a distance of sigma. So I'll just project this vertically as well. So now the distance between A and B, I can just call it sigma minus 30. And the distance from the center of the circle to point B or point A, these distances are both the same. And I'll call it sigma minus 30 divided by 2. So that's just half this distance here. The radius of the Mohr circle is also represented by this distance here, as well as this distance here. So I can now write 2 equations for the radius of the Mohr circle. So the first equation, if we look at this right angle triangle here, we can just use Pythagoras. So the radius r squared equals to this height here, 20 squared, plus this length here, sigma minus 30 divided by 2 squared. And this equation for r can be determined as, so say this entire distance is 100, so we can say that 100 is equal to the sum of r plus this distance here, sigma minus 30 divided by 2, as well as this distance here, 30. So the major principal stress (100) equals to 30 plus sigma minus 30 divided by 2 plus r. And I'll just tidy this up. So these 2 terms can combine together. So 30 plus sigma divided by 2 plus r. And I can rearrange this for r. So r equals to 85 minus sigma on 2. So now we have two equations for r and two unknowns, r and sigma. So I can substitute this expression into this equation here. So 85 minus sigma divided by 2 squared equals 20 squared plus, and I'll just break up this fraction just so it's easier to expand. So sigma divided by 2 minus, 30 divided by 2 squared. And now let's expand these brackets. So this works out to be this number plus sigma squared over 4 equals to 20 squared, which is 400, plus, and let's expand this term out. Sigma squared divided by 4 minus 15 sigma plus 225. Now these two terms cancel out, and if we add all the constant terms and the terms with sigma together, we get minus 70 sigma equals to negative 6,600. So sigma works out to be 94.3 kilopascals. And we can then substitute this value back into our expression for r. So r equals to 85 minus 94.3 divided by 2. So therefore r equals to 37.85. So this answers part 1 of our question, where we have sigma here. And part 2 of the question is asking what angle the plane of major principal stress, what angle this makes with the horizontal. So the angle that the major principal stress makes with the normal and shear stresses we know, this angle is called 2 theta. So because now we know what sigma is, it is now possible to find this angle here. So 2 theta equals to the tan inverse of 20 divided by 94.3 minus 30 divided by 2. So this works out to be 31.89 degrees. So therefore theta equals 15.94 degrees. And what this actually means in real life is that the major principal stress plane acts at an angle of 15.94 degrees above this plane. And this plane corresponds to this line here. Okay? So now, remember, the question is asking what angle the plane of major principal stress, what angle this makes with the horizontal. So, if this here is our horizontal, the total angle is 15.94 plus 20. So, to finish off, the principal axis acts at 20 plus 15.94, which equals to 35.94 degrees above the horizontal. And this concludes our series on Mohr circle. I hope you guys have found these videos helpful. Thanks a lot, guys.